Assalamu alaikum everyone. My name is Talha and today we're going to solve a problem at Leet code, which is number 414, finding the third maximum number, right? So let's jump straight down into the problem statement because that's the most important part of your problem, right? It's very important to get the details. So what's the problem statement? Given an integer array nums, you have an integer array named nums. That's something you'll be given as an input, right? The important thing is not nums. The important thing is that the array, the data structure, it has elements that are integers, right? Okay. What's the next part of the statement? Return the third distinct maximum number in this array. You're given an array of nums, an array of integers, right? So let's say nums equals this. So 1, 2, 3, 4, 5, right? So this is your array of integers. What is the third maximum number? Now, what do you mean by third maximum number? Imagine you have 3 boxes right here. One's red, one's green, one's yellow. Red one seems to be the largest one. The green one seems to be the second largest one. And the yellow one seems to be the third largest one. Why? Why do we call it the third largest, second largest, and the first largest? Because we can all agree upon this being the first largest or the largest one. What if this red box did not exist? Which one would have been the largest? Green, right? What if this did not exist? Which one would have been the largest? Green. Isn't that true? Okay, what if the green did not exist? Then the only largest we would have had would be yellow. True? Okay. So that means in case of green being present, green is greater than yellow, and green is the first greater one. And yellow comes next to it, right? Yellow comes after it in greatness or in largeness. Okay, so the first greatest is green, the second greatest is yellow. Now we have red. Red seems to be larger than green. So now this one has taken the first place. This one has the second place. And this one is third, right? Not quite good with art, but that's what I'm trying to apply. So 1, 2, and 3. What we need to find is this one, right? The third largest object, the third largest number. How are we going to find it? Okay, so like visually you can tell which one is the greater one, which one is the smaller one. You can compare them based upon your intuition, your experience. When it comes to computational problem, programming language, you have some constraints, some logical constraints, right? So how are we going to do that? Let's get right into it. All right. Okay, so 5 is larger than 4, 4 is larger than 3, 3 is larger than 2, 2 is larger than 1. So this is the first largest, it's the second largest, third, second, and the first. Red, green, yellow. Now this becomes red, green, yellow. You can perform the same pattern, or you can just remove this. 3 is red, 2 is green, yellow. But when we talk about comparing numbers in a data structure such as list, we can only access that data based upon indices. So we need to make sure that we place those elements in such a way that we have fixed places with a fixed pattern of where the largest will fall, where the second largest will fall, where the third largest will fall. All right. And in order for us to do that, we have a very simple way of doing this, right? In Python, what you can do, either use 2 for loops and keep pushing, the smaller one or the larger one to the left and smaller one to the right, and keep moving by using subtraction, all that stuff. But the problem with using 2 for loops is that the time complexity really skyrockets. And I've tried to use this, but Leet code wasn't able to run it. And so that's why I had to use the built-in function. First I used quicksort, but then I found out that you can use just sort, which is much better. It does the same stuff, and time complexity is quite normal. So that's what I decided to use, and that's what I'm going to do and show you how to sort how we're going to sort the nums array into a descending order, right? So why are we sorting it in a descending order? That's something we need to understand. But in order for us to understand that, let's come back to the second part of our problem. If the third maximum does not exist, what if you have only two elements? What are you supposed to do? Are you supposed to return the second largest? Is that true? No, because right now the first largest is this and second largest is one. They don't want to, they don't want you to return one. They just want you to return the greatest. That's what they're saying right here. If the third maximum does not exist, third maximum does not exist means the third element is not there at all. Return the maximum number, right? All you got to do is return the maximum numbers. In this case, 2 is the maximum number. So if 2 is falling on the second index, and 1 is falling on the 0 index, how are you supposed to return the greatest? How are you supposed to decide between which one is the greatest? Right? Which one is the greatest? Well, if you are putting it in the descending order, and if you move, let's say if I put it like this, nums equals 3, 2, 1. What if the 3 was removed? Now, on the 0 index, I have the second largest number, right? So still, at the 0th position, I can always return the largest number, largest of the two, right? So we're going to play with some conditions down there. But before we get into that, I need to explain a few examples here and explain the constraints that we're going to work in. All right, so you have nums equals to 3, 2, 1, right? In this case, it's pretty simple. It's in descending order. 0 is the first index is the second largest number, and the third is the first largest number, third largest number, sorry. Okay. Well, if you come down to this case right here, 1 and 2, well, you have 1 and you have 2. So if you reverse it with you 2 and 1, you have at 0th position, you have the largest number, and at the first index, you'll have 1, which is something that we don't want to return. Now, third case is quite interesting. What if you have repetitive numbers? Still, all you have to do is just arrange them as 3, 2, 2, 1, and just remove the similar number. So again, like if I put it like this, nums equals 2, 2, 3, 1. So what if you rearrange that into 3, 2, 2, 1. Now the one that's supposed to be the third largest number is falling at the 4th position, 0, 1, 2, 3. Sorry, the 3rd position, right? Third index, but at the 4th position. Well, now this is a problem because 2 is not the third largest, it's second largest, but it's occurring 2 times. So what we can do is just remove it, and 1 will fall back in its place. And we can do the same for all of the recurrent numbers. Just make sure you're only containing a single copy of them, not 2 or 3 copies of them. And I'm going to show you how to do that. But before we do that, let's sort. So the constraints are that the length of your array should be between 10,000 elements to 1,000, 1 to 10,000 elements. Should not be more or less than that. The numbers, the elements, the values that you're going to use as elements, it either has to be greater than negative 2 power 31, or it has to be less than 2 power 31 minus 1, right? So you can calculate that on your own time, but right now we're going to skip this. But these constraints are the ones that will make sure that your program is functional under sensible conditions, right? So, okay, now let's dive into sorting, the most important part. Okay, so how are we going to sort it? First of all, just do nums.sort. We want to rearrange the list in descending order. So reverse equals true. That will, if you print your nums, you're going to find out that you have you have 3, 2, 1. Now it's being printed in the descending order. Right now we haven't arrived at our final answers, so that's why it's showing wrong answer, but that's not to worry for now. Okay. Now what we're going to do is we're going to make sure that we don't run into this problem of replication. For that, what we can do is for I in nums, right? Iterate through the nums, your elements in your nums array, and see if I is not in empty list, right? Empty list dot add I. Very simple. Empty list. Create just an empty data structure as a list. Okay. What this loop is going to do is it's going to see, it's going to go through one of these arrays. Is going to go and see, let's check. Okay. So I is going to go, hey, I've got a 2. It's going to go to the empty list. Empty list. Does 2 already exist inside your domain, inside your bracket? Empty list, no. Okay, could you append that for me? Could you add that in your list? Empty list, why not? I think I like it, so I'm going to add it. So it's going to add a 2 right here. Okay. Then it's going to go back to 2. Hey, I've got another 2. Do you have space for another 2? Empty list. Nope, I don't. Based upon your condition, right here. Okay. Hey, you got a place for 3? Empty list. Yeah, sure, no problem. 3 goes right into the empty list. Again, hey, I've got a last thing for you. Yeah, what now? All right, I have 1. Would you like to append that for me? All right, fine. So now, since this was already sorted, right? So this should look like 3, 2, 2, 1, and it will only append. Once you append that, it will look something. Your empty list will look something like 3, 2, 1, leaving 1 at the second index, 2 at the first index, 3 at the 0th index, which will be 0, 1, 2. All right. So I think it looks good. Now we have already appended that. We're going to move unnecessary information from here. Rather than empty list, I'm going to type it as sorted list. Looks much better. You know, in software industry, we have to make sure that we're using appropriate names. We're not coming up with meaningless words that later on create a mess for you. All right. So now it has been appended. We have a reverse list. Now, what we need to do is we need to basically see, okay, if we have 3 elements or more than 3 elements in our array, in our list, 3 elements or more than 3 elements, what we can do is, since we have already arranged that in descending order, what we can do is we can take the second index, and that will be our third largest number, right? But what if we have less than 3, right? What if we have less than 3? Then what we do is we return the one at the first index, right? Let me show it right here. Okay. So this is a list, right? This is a list. So I arrange it in 3, 2, 1, right? Right now at 0th position, we have a largest number. First position, we have second largest. Third position, we have second index, we have third largest number. What if I remove that? Well, 2 will move right here, 1 will move right here. So At 0, we have 2. At 1, we have 1, and this remains empty. So bracket closed. So if we are asked that return the maximum number, not the second maximum, all we have to do is just return this index regardless. So this will make sure that we're returning the maximum number regardless of what the situation is, what the number is, if it's 5, 4, if it's 4, 3, it doesn't matter. Okay, so now what we're going to do is, let me think. What do we need now? Okay, all we need now is basically conditions, if conditions, right? So right underneath for loop, I need to put new conditions. If length of our sorted list is basically if length of sorted list is greater than 2, that means it's either going to be 3 or it's going to be more than 3. Still, all we have to count is 3, right? So as long as it's greater than 2, it's going to be 3. So it doesn't matter if you have 1,000 numbers or 10,000 numbers, we're going to consider the first 3 because we are considering the descending order. Good enough, right? Okay, so now we have greater than 2. Now all we need to do is return. What if we have 3? Return the second index, right? 3, 2, 1. 1 falls at the second index, right? 2 index. So what we're going to do is return the index, since we're storing everything in the sorted list, the sorted list return second index, right? Okay, and else return, which means that if we have if the condition is that the number of elements in the nums is not greater, either it's going to be great, either it's going to be equal, or it's going to be less, right? So if we have 2, we return the maximum number. If you have less than 2, we still return the maximum number. In that case, we'll have 1. So return sorted list, which will be 0. All right, so I think our solution is complete. We have considered all of these 3 example cases. We arrange that in descending order. If we have 2, we return the maximum number. If we have repeating numbers, we add that into the empty list and make sure that we don't have any more repeating numbers, and we take that sorted list and perform operations on it, right? So let me run the code and let Leet code decide if my solution is going to work. Okay, so I made a mistake here. It's sorted list, right? I hope I'm not making the same mistake anywhere else. All right, so test case has been passed. Let's look at the 2, 2, 3, 1, right? I'm going to remove this and take this repeating number case. All right, so that case also passed. And now we need to look at this one, the weird one. Pass. Now we need to submit our code. All right, before we submit our code, let's discuss the time complexity. So what's the time complexity for this one? The time complexity, since we have one for loop, and the sort algorithm also uses for loop, but it uses for loops separately, right? It does not use nested for loops. Same goes for quick sort. You can look up the algorithm, but that's what it uses. So O of n, O of n, O of n, O of 3n, we ignore the constant, so we have O of n complexity. So O of n complexity will be, the more you increase the input, the more time it will take. And right now, since we have 1, 2, right? In this test case, we have 1, 2, and the time complexity, the time it took was 40 milliseconds. What if I increase this? What if I increase this to 1, 2, 3, 4, 5? Now, bear in mind, it took 40 millisecond, right? Now, let's try for this one. For more input, it should take more time, right? So hence we approve open complexity, right? All right, come on. So it took 40 or 42, now it's taking 52 millisecond, right? And all of our test cases actually are going to pass. Yeah, it's a lot of practice to do. So success, all the test cases passed. So this solution is going to work. All right. So this was our third. This was our finding the third maximum number, which we have found out. And yeah, I think that's how it works. Output equals 3, expected 3, whatever case you take, it's always going to work. It's worked for me, but I think if you go beyond the constraints, it might not work. I haven't tried it, but yeah, I'd love to try it sometime. So let me think, what else do we need to discuss? Well, we have verified the time complexity. We have walked through the examples. We have recorded the solution. We have discussed the time complexity. We have the talk about the solution, and we have talked about some constraints. We haven't been able to explain test edge cases. Well, we'll talk it sometime. All right, so let's move on to another problem, and it's a very interesting problem. All right, so the next problem we're going to solve is crawler log folder. Now that's a very interesting problem that I was able to work on. Took me a couple of hours to figure out what the question really meant. That's why it's really important to understand the question first and really understand it, what it really means. Your understanding should make sense to yourself as well. Well, let's get into the problem statement. The Leet code file system keeps a log each time some user performs a change folder operation. The operations are described below. Period, / move to the parent folder of the current folder. If you're already in the main folder, remain in the same folder, right? Okay. Period / remain in the same folder. Remain in the same folder. Okay. Remain in the same folder, and x / means x means that any name of a directory. That means that move to the child folder name x. That means that you're moving from one directory to the child directory, right? This is what you might come across it in Linux as well. It's basically / is the king right here, and a lot of operations along with it. So, well, let's move down and finish reading this. You're given a list of strings logs where logs of I is the operation performed by the user at the ith step. The file system starts in the main folder, then operations and logs are performed. Return the minimum number of operations need to go back to the main folder after the change folder operations. All right. So basically, what Leet code is doing is whatever operations you do, if you're moving from one directory to another directory, it's recording the operations that you perform, right? So let me try to illustrate here. Let's see if we can solve this by illustrating. Okay, so these are two brackets. Okay, let me take the example. The first example is, well, it's a huge string. So let me copy this, copy and paste it right here. Okay, looks good. So you're in D1, right? Then you move to the D2. Then you basically put the command to remain in the same directory. Then by being in the same directory, you move to D3, another child folder. Then you try to go to the main folder. You're in D3, and then you went back to D2. right? Because D2 is the parent folder of this child folder. And then you move to the D31, right? You move to D31, which is another, basically what you did here was you started with D1, you went to D2. By staying in D2, you went to another child folder, D3. In D3, you went back to, by performing this operation, you went back to D2. And then inside D2, you had a D31, and then you ended up in D31. Now, how many moves will it take you to get back to the parent directory, the main directory? And this represents your main parent directory. Your parent directory is basically D1, right? So, well, there are two perspectives to look at it. Either you loop through it. Well, if you want to go to the main directory, if you just treat it as an element, you're going to end up right here. Okay. Well, is it going to take you one move to go to the main directory? Well, you're in D2, and then you're in D31. Okay. Well, technically, it should take you one move to go back to the main directory, right? But then there are operations. Okay. But what about the main parent directory? D2 is the parent directory of D31, but D1 is the parent directory of D2. What you want to do is you want to go back to D1, right? Because that's where all the story started. If you look at the diagram, it might make more sense. You're in D1, you went to D2. In D2, you went to D3. In D3, you went back to D2. And from D2, you went to D31, right? Now you want to go back from D31 to D1. Is it going to take you one step? Because according to the logs, you only need one iteration to go back. But in functionally, you have to go to D2 and then D1, because that's how Linux works. That's how operating systems work. So just iterating over it and using -1 +1, it's not going to work. What if you assign, if this is 1, 1, this means 0, this means 1, this means -1, and this means 1. Well, if you add these values, so that will be 2, 0, and +1, 3. You need 3 moves to go back to your parent directory. Doesn't that sound good? If you're moving it to child directory, you assign it a value of 1. If you are staying in the same directory, you're not doing any motion, so just 0. If you're moving back to the parent directory, assign it a -1. If you move to child directory, 1. So 1 - 1, 0, and 1 + 1 + 1, 3. You need 3 moves. So this is a case right here. Well, the answer is right. 3 moves, right? Well, not so fast. Now this 1, 0, and -1 theory may also apply right here. It also applies right here. So 1, 1, -1, 0, and then you have 1 and 0. So 2, 1 + 1, 2. Seems right here. But as soon as you come right here, this means -1, -1, -1. If you add them, you have -3, and then you have 1 for this. So 1 - 3 is -2. Well, what does -2 mean? Are you going back from your root directory or your main directory back to what? Like something does not exist, right? So the 1, 0, -1 will not work here, right? Instead, what we should do is we should look at the real life scenario. We're going to ignore these operations, and all we're going to do is going to iterate over D21, D2, and D1, right? All we need to do is basically go from ignore these, because these don't mean anything. We're just looking at the location, we're looking at the data, right? And we're just trying to do some smart work here. So we just move from D31 to D3, D3 to D2, and D2 to D1, right? So how many iterations do we need? 1, 2, 3, okay? So we have 3. What about this case right here? The example number 3, right? We're going to ignore all these 3, right? We are already at D1. So from D1, you cannot go back. You're already at zero index. So all you return is 0, right? Go back to this example right here. Ignore this, D21 to D2, 1 and 2. Ta-da. Oh, this is our solution, right? Okay. All right. So let's get into typing the solution. Okay. So in this case, what we're going to do is we're going to use stack, right? Stack is the best option I could think of. Stack, how the stack work is, it works on the rule of LIFO, which means last in, first out. Okay. So 1, 2, and 3, and 4, right? So let's say if I have an element 1, 2, 3, and I have a list here, 4, 4, 4, and I want to make sure that I want to add one element right here. Okay, I think it will be last in will be the first out. Okay, so what I'm going to do is take the last element that I inputted. I have to take it out first and then replace that with number 4. So I have to free the memory space in order for me to add it, right? That's how stack works. 2 and 4. This is how it's going to look like, right? Since we want to ignore these kind of operations, what we can do is we can remove them. We can empty their memory spaces and compact to our list so that we are only iterating over or the elements that we want to iterate over, like D1, D2, and D21, right? So let's define an empty list or empty stack list, which is equal to stack equals to empty list, right? Now what I'm going to do is let's take a random variable folder in our logs, which is our input logs, right? And if folder is equal to, right, is equal to this, right? If folder is equal to this, if folder is equal to this, stack dot pop, right? Which means that if you're iterating over this list, right, and you find out that your folder variable found out that there was an operation like this, an operation like this, just pop it out, just kick it out, right? But and kick it out, right? Okay. So once we kick this out, D21 will take its place, right? That's how it's going to work. So if you go back, we had 4 here. Okay. This will be kicked out and 4 will take its place. So 1, 2, 4. Okay. And the next we want to do also for this operation right here, we want to ignore this one as well. So elif folder is equal to / well, we need to do we're ignoring this one. Why are we ignoring this one? Because this means nothing. You're staying in the same directory. So we don't need to even consider it or pop it, just pass through it, right? This one meant something. This is an operation that takes us back into some directory. So we're just popping it out. We can also pass it, but popping it out, it's going to help us a lot, right? And the third condition we need to pass is basically, something's missing. Okay, what if inside our stack, there's an empty space, like 1, 2, this is an empty space. Do I still need to pop something out of this? No. If this is not equal to 0, right? If this is not equal to 0, if this is not empty, there's already something, then you pop something out. If this is empty, you don't need to worry about anything. You don't need to run that operation. So all you got to do is add another statement right here. If and, right? And length of stack is not equal to 0. It's not equal to 0. That there's something in the stack that you're popping out, right? So then you stack.pop and then go to the elif and apply the same. What if, okay, just leave it like this. We don't need to worry about this one right now. So the pass and else. Okay. All right. So what we're trying to do is we are taking these two out. We have taken these two out. What do we need to do? Once we take these two elements out, what do we need to do next? We need to append them, right? We need to put the elements that we want to. If you're taking 3 out, we need to append 4 right here, right? So we have to run the append, right? So, I mean, it's going to move itself, but let's say we don't have any conditions, like we don't have either this operation or that operation. We just need to keep appending elements, and then it's all going to make sense later on. So stack.append, and we're going to use folder, right? Okay. Now we need to find out whether stack has recorded all the right elements. And in order for that to, in order for us to do that, print stack and return stack. Okay, sounds good. Okay. Okay, indentation doesn't match. This is always an issue. Hope this works now. Okay. Okay, so we have a D1 and D21. In this case, we had a D1 and D21, right? What about D2? Where's it going, right? We have missed something here, right? Okay. What if we come across something like this, right? And at the same time, the length of stack is 0. Okay. What do we mean by that? Okay. So we have a problem here, okay? We have D and D21, that's fine. We have a D and D21, that's fine, okay. Okay, what if our stack is absolutely empty? What if we don't have any element, right? What if we don't have any element? What if we cannot move at all? Just like in this case right here, we cannot move anywhere, right? We have only one element, and all we have is, since we're moving from the right to left, all we have are these kind of elements. So we're going to keep ignoring these, and then what if we don't even have a D1, right? If you have these and we don't have a D1, that means we are already in the main directory, right? So in that case, what we can do is basically length of stack, right? Length of stack is equal to 0, and folder is equal to slash what if we are in the current directory and we also don't have anything in here. What we're going to do in that case is we need to pass. We're not going to append anything. We're just going to keep it like this. We're going to keep it D1, right? So we don't have anything in the stack, right? And we don't have anything, and we have something like this. We're going to pass it. Okay, so let's run this and find out if it works for us. Interesting. So let's see where we went wrong. D1, D2, D21. Okay. So folder and logs, folder equals to this, length of stack is not equal to 0, stack.pop, elif, folder is equal to pass and if length of stack is equal to 0 and folder is equal to pass, we pass on to that, else append folder, print stack, and return stack. How will this work? It's falling out of the function. And okay. Mhm. Okay, so we're getting D1 and D21, right? And expected is 2. Oh, okay. So what we need to do is we need to return the length of stack. We don't want to return the stack itself, but the length of stack, right? So we need to return the count. How many moves will it take to move to the parent directory? So now it's been accepted, right? Whatever edge case I use, the test case I use, it's always going to work. Let's try it out. So let's use this one, example case, right? Paste, run code. That worked. And this one right here, which is your edge case, copy this, paste, run code. And it should work. I don't know why lead code is taking so much time. But regardless, yeah, it worked. It worked for me earlier. It's going to work now since those two were properly working, but we're going to wait for lead code to do its thing. If we submit it, I'm pretty sure it's going to. I'm going to pause this video for a while until this gets done, so we're not consuming too much time. All right. So yeah, you guys can see that it ran fine. The runtime is 45 minutes millisecond. What about the time complexity? I think it's pretty simple. All of these are you know, constant statements. They're not going to change. They're not going to change anything except for this for loop is going to be an often complexity. The more we increase the number of elements, like in this case, we have 45 milliseconds. So it should increase as I increase the input, which is basically, let's say if I were to do this. So instead of 45, it should give me more than 45. Invalid test case. Okay, it's invalid test case. I don't know why it's doing this. I think, oh yeah, we need more comments here. So // and run this. Now we have more operations here. Should be, let's try this a little more. So if it's O of n, it's taking 34. So the time is reducing every time. Well, I think it's O of n minus 1. If that's the case, then the more we increase the number of elements, the less time will it take to process to run the program. Well, I think it's O of n minus 1. If I'm incorrect, kindly correct me. But this is my understanding. So let's submit it and see if it passes all the test cases that are there. And yeah, ta-da, it all passed. Well, this was all for today. I think we have went through all the points. Let me take a look if I've left something. I might have left something. All right, so we have discussed what the problem is, what the solution is, why we use the solution, and what the approach should we take, and the approaches we cannot take, and we are using stack data structure, and we just verify the time complexity, which I think is O of n minus one. It reduces with more input. I still have to search about that. Well, thank you all for watching this video. I hope you enjoyed this video, and any feedback is welcome. Jazakallah khair. Assalamu alaikum wa rahmatullahi wa barakatuh.